Today's class we will go for Huffman coding, which is one of the example of greedy algorithm. Before starting Huffman coding and where it is useful, we will go for one simple example. For example, if any person wants to send any message to another person, he will take any one of the electronic device, for example, mobile. Next, another person also required another electronic device, which is also mobile. So he wanted to send some information like, "Hi, how are you?" This message wants to send from this device to this device. So how generally data transmit? Let us understand. So data is nothing but this text as it is character never transmit from this mobile to this mobile. How it will be transmitted? Initially, this character is going to be converted to binary form. Okay. Next, this binary message will transfer to another person. Means this is receiver. This receiver receives the binary data. This binary data again coded and it generate the same message which is transferred from this mobile to this mobile. This is the way generally text message can be transmitted between two devices. Now, how this binary format is created by using this H. So, American Standard Code for Information Interchange. This ASCII is one of the table which contain a unique representation of each character. Okay, I will show that one. This is one of the ASCII table. So here this is the ASCII character. This last column is the ASCII character. Okay, so generally we have communicated the two persons either in English alphabet or any other alphabet. So here English which contain uppercase letters and lowercase letter. And every character is associated with one unique number. Okay, this is the ASCII number. So here it is decimal representation, but generally in which format data can be communicated? In binary format. So when a person send capital A, this capital A never directly sends. Instead of this A, this code is transmitted. Okay, so this A is encoded to this binary representation and receiver can receive this binary data and decode. When he decode, he will get A character. Okay, this is the way data can be communicated, exchange between two devices. So let us know one simple example. I have taken this data. So this alphabet, like this character is some set of characters. This message I have traversed, I have transferred from A device to B device. So let us observe how many characters is present in this message. So 25 characters are there. So I am conveying you traditional method. Traditional method means which we discussed right now. So here 25 characters are there and each character is going to be converted to how many digit length? So if you go for this example, A is one character. This is represented by this one. So how many digits it contain? 1, 2, 3, 4, 5, 6, 7, 8. So every character is having 8 digits length of binary number. So here this A This A is represented by 8 bits. This B also represented by 8 bits. So 25 digits string is mm, represented by 8 digits. So total how many character? 28 into 8. 200 bits of string is created. Transmit this message in between two independent devices. These are two independent devices to exchange information for these 25 bits of length, 200 bits of data it is transmitted. Instead of sending 200 between two devices, we reduce the number of bits. If we reduce the number of bits without losing the data, at that time, is this data can transfer faster than this previous method or not? So 200 bits it is transmitted. For example, each bit is taking 1 unit of time transfer from X device to Y device. So total 200 units of time it requires to transmit the data. So if I reduce the number of bits, definitely it will be transferred better than this time. Okay. How can we do this one? We will learn. So here directly I never go for this Huffman coding. So other than this traditional is ASCII characters. Okay. Instead of ASCII character, we can go for our customized coding. Let us know what is customized coding. So here I am going to write. So here the same message again I have represented in another sheet. So this is the message, actual message I need to be transmit. So here, if you observe this character, what are the characters were presented here? A, B, C, D, E. These only 5 characters are there. A, B, C, D, E. Previously, how it was represented? The 8 digits string. Instead of 8 digit, I will go for my customized coding. So let us know how can I create customized code. So let us instead of 8 bit length of string or binary string for this character, I am going to take 1 digit character. So 1 digit means either 0 I can write or 1 I can write. So here this is going to be represented by A, this is going to be represented by B. So when you take only 1 digit length of binary information, so it is possibility to represent only 2 characters. How many characters I have? 5 characters. So what can I do? I will go for 2 digit length of string. So 00, 01, 10, 11. So maximum how many combinations I get? 4 combination. This is going to be represented by A, this is B, this is C, this is D. Still I need another character to represent a code. So these two are not enough. I will go for 3 digits. So 000, 001, 010, 011, 100, 101, 110, 111. So when it is 3 digits, how many combinations I got? 8 combinations. How it is generated? Very simple. Based on your character, you can easily identify how many digits of string you require. So here, when it is 1 digit, so 2 to the power of 1. So total 2 characters. When you have 2 characters, you can go for this 1 digit. So if you have more than 2 characters, then you can go for 2 to the power of 2. So total 4. 4 combinations did you get or not? Yes, let us go for 2 to the power of 3. to the power of 3 means 8. So if you have 8 or less than 8 bits, you can go for 3-digit character. Let us go for example. If you have 14 different characters are there, then how many digits of length is required? So 2 to the power of 3. 3 digits length is enough? No. 3-digit length, you can maximum write coding for 8 characters. But how many characters you are expecting? 14 characters. Then what can I do? I will go for 4-digit length of string. So if it is 4-digit, so it is going to be give this many combination. 2 to the power of 4 means 16 combination. You can give maximum up to 16. But how many you have? 14 only. So 4-digit length of binary string you need to take. Okay. So this is the way you need to identify the coding. So this A is going to be represented by 3 zeros. E is represented by 001. C is represented by 010. This is D. This is E. So, these three are empty. Here I did not map this combination to any character because these characters I do not have. Other than these five, I do not have any character. So that I am going to making this as empty. I want to use only this data. Using this data, I want to prepare a information. So here, how this data can be transmitted? Instead of this 0, A, what happened? Which data it is created? 000. What is B? 001. What is B? 001. What is A? 000. Like that, another string is formed. Instead of sending this one, this binary information will be transmitted. So if I observe this type of coding, what advantage you get? So previously, how many digits you have taken to represent this capital A according to ASCII? 8-digit length. Now, how many digits you are using? 3 digits. What happened? Total 25 characters of string, and each character is taking 3 digits of binary coding. Then total 25 3 75 bits of data is created. But previously 200 bits. Now 75 bits of data it has created. Here you get one more problem. What is that? When it is traditional method, the receiver can understand that this data is transmitted according to the rules of the traditional method. Means they follow the ASCII decoding. So did you remember this? Previously, which data transmission I have used? Traditional method. What is traditional method? It has represented by 8-bit binary information. So here, when I do not transmit any in other information, by default, this receiver can consider that data which is transmitted from sender to receiver data is the traditional method. So it this device will follow the coding of ASCII. Okay. Coming to here, are you using ASCII? No. This is customized coding. It is customized coding. When you transmit the 75 bits of data, receiver cannot understand whether you have used this type of coding or ASCII coding. Is that clear? So here, to resolve such problem, along with these 75 bits of data, I need to transmit coding also. What type of coding I have applied on this string, that information also I need to be transmitted. What type of coding I should transfer? While transmitting this information, you should follow the traditional method. So what is the rule of traditional method? This A is represented by 8 bits. So how many how many characters of data you have? Only 5 different characters were present in this string. So these 5 characters, this 5 character traditional method is coding. Coding is sending according to traditional method. So when it is traditional method, 5 characters. Each character is represented by 8 bits. S These three digits I need to transmit for every character. So how many digits are there? Three digits for each character. So total additionally 5 into 3 characters. This is the customized code character. This one is the character. Okay, 5 characters. 5 is representing A, B, C, D, E. 8 is nothing but ASCII code for this one. Okay. How this ASCII code is converted to this format? Using these 5 digits of 3-digit length. This additional information also I should transmit from client machine to transmitter to receiver side. So let us understand how many digits of data it is transmitting. So total 75 is the actual text. Okay, plus 5 8 40 digits is for this character. Yes. 5 3 15. 15 digits of this customized code. So this many bits are transmitting when you go for this type of coding. So let us understand. So 75, 80, 90, 90 plus 30, 120. 120 bits right now it is sending. Previously, how many bits it has transmitted? 200 bits. So did you reduce the number of characters or not? Yes, I have reduced the number of characters. So which data is transfer faster than faster? This 120 bits or this bits? 120 will be neatly transferred. So you may it will take 120 bits data faster transmission. This is one thing. And if you want to reduce the size of your text, it's compression. So it increase the speed of transmission. Okay, this is one advantage. Second one, you may take this one as a data compression. Data compression. Okay, I have reduced. Same. Is there any data less? No data less. Data never loss. But what happens? That same information I have converted from 200 bits of data to 120 bits of data. Here you achieve a little bit advantage. But Huffman, this person has proposed new method to reduce the size. How he reduced the size, we will understand. This was proposed around in 1953 when he was doing a PhD in MIT University. So let us know how this person has proposed that one. Let us understand. So for example, this is the message. So here, first requirement is I need to know how many times each character is repeating. So here, A is one character, B is one other character, C, D, these characters were present in this string. So let us understand how many times each character is repeating. A is repeating 1, 2, and 3, 4. 4 times A is repeating. Next one, let us know B. 1 time, 2 time, and 3 time, 4 time, 5 times, 6 times, 7 times, 8 times B is repeating. Next, let us know how many times C is repeating. C 1 time, 2 time, 3 time, 3 times C is repeating. And let us know how many times D is repeating. 1 time, 2 time, 3 times, 4 times, 5 times. 5 times D is repeating. Let us know how many times E is repeating. This is 1 time, 2 times, 3 times, 4 times, which is also repeating 5 times. So 5 times, let us understand whether it is equal to 25 or not. 5, 10, 13, 21, 25. So 25 characters we got, this one is matched. So this many times each character is repeated. So here, this is one of the greedy method I said. Greedy method is for optimization. So it is minimization problem. So I want to reduce optimization solution I required according to the greedy rule. And one more thing, either that optimization is minimization or maximization. Is this problem you are working for minimization or maximization? I need to reduce the number of character. So definitely it is minimization. Let us know how to find that one. So when it is minimization, I need to what we call put these all values in the ascending order. Okay, let us know how it is created. Initially, very less number of times this 3 is repeating. So 3, the character is C. Next one. What is the next one? 4. It's 4. And which character is repeating 4 times? A. Next, this one is also completed. Next, 5. So D and E both are repeating 5 times. You can write E followed by E, E followed by D. There is no any difference. So here I am writing D, which is repeating 5, and I am writing E, which is also repeating 5 times. So these two is completed. Next, remaining character, which is B, and which is repeating 8 times. Now what can I do? I need to create a code for this one. Let us know how this code is generated. First, step 1. What is this step 1? Initially, I need to identify which two characters are less number of times it is repeating. Which two characters are less time repeating? C and A. C is repeated 3 times, A is repeated 4 times. So while writing this one, left side, I'm going to draw the tree. If this tree is forming, you can understand. So first one, C. C is the character. Next one, A character. C is repeating 3 times. A is repeating 4 times. Okay. Next, what can I do? I need to perform summation operation on these two. So here, 3 plus 4 is value equal to 7. This is created. Now what happened? These two are converted as a 7. Once it is completed, again you need to sort this one according to the numbers which are generated newly. So here you can't see 3 and 4 right now. This 3 and 4 has converted as a 7. So let us know what happens when I do sort. If I do sort, which is the minimum again? This D comma E is minimum. D, which is 5 times. Actually, this is column wise I have written. Now I am going to write in the row wise. Next one, E, which is 5. So 2 5s is completed. What is the next one? Is it 8? No, we have 7. 7. Which characters are 7? E, 4, C, C, C is 8. Next, what is the remaining character? Which is repeating 8 times, and which character is B. So this is the way we have sorted. Next, step 2. What is step 2? What is the thing I have done it here? I pick the two characters which is less number of times it is repeating. Again, from this string, you need to find two characters which is very less number of times it is repeating. So if I observe this one, D comma is repeating very less number of times. So D, E, which is repeating 5 times, which is repeating 5 times. What I did at this place, I have performed summation operation, means addition I have done. Similarly, I want to perform addition. So I got, okay. Once it is generated, again you have to apply the sorting. So now, what characters are there? These two become n right now. Okay? I'm confused by seeing these things to understand how it is formed. So these two become n, 7, 8. Again, I need to resort this one. So what happened? This will become n. So 7 is the smallest. 7 I am writing. 7 is formed using E, 4, which is C, this is A. Next one, 8, it is character B. Next one, is 5, 5, and characters are E. This is the way I have written. Next. Yes. Once it is completed, again, what can I do? I need to pick uh, two things, which is very less number of times repeating. So 7 and 8. So how it is going to be formed? You observe here. This is 7 and this is 8, where 8 is B, 7 is formed using 3 and 4, and 3 is C, 4 is A, and this is B. Now what can I do? I need to perform summation on these two. So 7 plus 8, which is 15. New digit is formed. So which is step number 3, which is completed. Again, what can I do? I need to perform sort. When I do sort, what happened? So same thing. This one and followed by sort also I am writing at the same place because we need time to write the coding. Otherwise, I will rewrite this one. So here this is 15. This is 10. Which one I should write first? 10. So 10. This 10 is formed from 5. 5. This 5 is D. This 5 is E. Next one is 15. This 15 is generated by 7 and 8. And what about 7? This 7 has generated from 3 and 4. This 3 is C, this 4 is A, and this 8 is B. Right. This is the way I have sorted. Next, what can I do? I need to perform summation. So when I do summation, what happens? 10 plus 15, which become 25. This 25 is the first. When you get this 25, if it is matching with the this one, you can stop off processing. So this is one simple technique to remember whether your tree is completed or not. So the root node and number of digit definitely matches. Now we have completed the tree. Now how can we generate the code from this one? So here from this root node, if you go towards the left side, you need to assign 0 for the edge. If you go towards the right side, you need to assign 1 for that edge. Okay, is that clear? If I go towards the left side, I need to assign 0 for that edge. This is a traversing technique. Let us know how it is going to be formed. So initially, now I am going towards the left side. So this is 0. I got 10. So is this 10 characters frequency? No. This has generated from 5 comma 5. So again I need to go towards the left side. 0. So here you reached 5. What is this 5? It is the leaf node. So it has generated using D. So let me know the code for D. 0, 0. I am writing 0, 0 for this D. Next, may I know what code I should give for this E? So 0 going towards the left side, and from 10 I am going towards the right side. So which digit I should give? 1. So tell me the code for E 0, 1. And this is 0, 1. Next step. Next step. So these two digits were completed. Now I will go towards the right side. So right side means which character I should write, which binary number I should write. So this is 1. I am going to write for C. 1 is right side. And from 15, I am going towards the left side, 0. From 7, again, I am going towards the left side, 0. Give me the code for C, 1, 0, 0. So C is 1, 0, 0. Next up. For A, 1, 0, 1. I'm going towards the right side. So 1, 0, 1. This is right side. Next, I am going to write for B. So 1, again, I am going towards the right side. So again, 1. So 1, 1. So this is the code created according to the rules of man. Okay. So if you observe the previous code, which has taken 120 bits, where is the fixed length of string. Which string? Binary information or binary string. You may call it as a binary string also. Fixed length binary string you have created for each character. Either it in additional or your custom coding, you have taken fixed length. But when you go for Huffman code, each character is represented by same size? No. Here C is represented by 3 digits, B is represented by 2 digits. So is it fixed length? No. This is called variable length. This is called variable length. So Huffman code is fixed length or variable length? Variable length. Let us know how much, how many bits of data need to be transferred from sender to receiver, or how many digits of data I can represent the same information to less number of bits. Okay, compression. Let us know how it is, much bits it is taking. First one, what can I write? Number of uh, characters. So can I go for directly 25 into 3? No. Previously, I have written directly 25 into 3. But this time it is not possible because every character is represented by different length of string. So here, A. I know how many times A is repeating? 4 times. 4 times. What is the length of your code for A? 3 digits. So 4 into 3. Yes. B. How many times this B is repeating? 8 times. What is the length of this binary code? 2 digits. Yes. C. How many times C is repeating? 3 times. What is the length of this code? Plus. Plus D. How many times D is repeating? 5 times. What is the length of this one? Next E. How many times this E is repeating? 5. What is the length of this one? So this is for actual message representation. So how can I rewrite this one? 4 3 are 12, plus 8 2 are 16, plus 3 3 are 9, plus 5 2 are 10, plus 5 2 are 10. This is actual message. But is this coding known to end user? Not end user. Is this code known to receiver? Receiver don't know. And if it is compression technique, you should provide what type of coding you have used for generating this type. So that again, what can I do? Traditional method of character encoding. So 5 digits are there. This is the actual length of string. Let us count what is this sum. 10, 20, 29, 39, 39 plus 6, 45, 55, 57. These 57 characters of original string plus these 5 characters into each character is represented by 8 bits. This is traditional method as coding. How many bits are there? 3, 6, 7, 8, 9, 10, 11, 12. 12. 5 8 are 40 plus 12. This is 52. So this 57 is the actual string and 52 is the coding. So 7 plus 2, 9. 5 plus 5, 10. So how many bits of data it is transmitting between two devices? 108 bits. Okay, who proposed this method? Huffman. What about the customized coding for the same string? 120 bits. What is traditional? 200 bits. So did I reduce number of bits or not? Yes. How can we achieve this one? Using Huffman coding. Okay. So when you use this mechanism, you can reduce the size of the file or you can reduce the number of bits without loss of this information. Okay. So this is one of the data compression mechanism. So let us understand how this was created. One more thing. Now we need to know how this decode can be done at the end user. So for example, I'm going to write a random string. This is decoding process. Encoding, we understand. How this will be encoded? So I'm writing at this place A. What is the representation of A? 101. What is the representation of B? 11. What is the representation of B? 11. What is the representation of A? 101. What is the representation of C? 100. 100. Like that, the string is formed. How the receiver know whether it is when it is fixed length it has taken and decoded. But when it is variable length, how it is created? Okay, let us understand. So here, using this code, this tree is formed, and this by using this tree, let us compute decoding process. So I am writing 100, 100, 101. Next, double one. This is the string. Let us consider I have transferred from one device to another device, or I have applied the compression mechanism it has created. What happens? It is do the traversing mechanism. So let us know how does this traversing can be done. So it will read the one character. So when it is one, which side it will go? This side it will go. Next, again zero received. This side it will traverse. Next again zero. Next is zero. Next again one. So is there any path that go towards one direction? No. So it has stopped. When it is has stopped, this is the leaf node. For each iteration, it will check whether it is the leaf node or not. Once it is leaf node, it can replace the character. So 100 is completed. There is no any character to be made. So immediately it stops and it is going to be represented by C. Once character is generated, again your control goes back to the root node. So what is the another character? 1. It goes towards the right side. 0 means left side. Next 1 towards the right side. So here it is reached the leaf node. So what is the character associated with this one? A. So C A. So up to this part is completed. Next 1. 1 means it will goes towards the right direction. Again, what do you have? 1. Again towards the right direction. Is it leaf node or not? When it is leaf node, what happens? Is the character associated with this one will be presented. What is this? B. cab. Cab is the character data which has transmitted from client machine or sender to receiver side using this code. Do you understand how the data is decoded at the receiver side? Yes. So cab is the message he transferred. This has converted to the binary form. Which binary form? Huffman binary form. This message is transmitted and decoded according to string. Okay, this is Huffman coding, encoding, and decoding.